Welcome to this CableCALC Pro video demonstration. In this video I'm going to perform several example calculations from the standard AS3008. The first example is for a buried three-phase circuit. The following data is taken from the example in the standard. The cables are PVC V75 single core. The copper conductors must be 400 mm squared and the load current is 1500 amps. The objective in the problem is to calculate the minimum number of parallel active 400 mm square conductors required for the following four buried installation scenarios. The first thing we do is set up the common cable type, supply, and load settings for the problems. Note that the length of the run is not given, so voltage drop will be ignored. We can fix the cable size to 400 mm squared and increment the number of parallel three-phase circuits until compliance is achieved. The first scenario A is for all cables in one conduit. The installation condition is already set correctly. Next we open the derating wizard. According to the standard, for this scenario, the derating factor shall be calculated based on all the circuits inside a single duct as being enclosed in air. The overall derating factor as per table 22 is 0.6 for 5 enclosed circuits. As can be seen, the current rating of 5 derated three-phase circuits is only just short by 24 amps. Therefore, 6 parallel three-phase circuits are required for this scenario. The second scenario B is for each parallel circuit in a separate conduit. The installation setting is correct as buried enclosure combined. A new derating factor is calculated starting with 4 groups of buried circuits. The single core cables are enclosed combined and each of the conduits is touching. The overall derating factor as per table 26.2 is 0.79. Therefore, for scenario B, a minimum of 4 parallel three-phase circuits is sufficient. The third scenario C is for each and every single core cable to be installed in a separate duct. The installation condition is changed to buried enclosure in separate ducts. The derating factor is calculated for 4 buried groups in separate enclosures and touching. The overall derating factor is 0.74 as per table 26.1. Therefore, for scenario C, a minimum of 4 parallel three-phase circuits is required. The final scenario D is for direct buried and spaced three-phase circuits. The installation condition is changed to buried directly. The derating factor is calculated for only 3 direct buried groups, spaced at 0.6 meters. The overall derating factor as per table 25.1 is 0.87. Therefore, for final scenario D, only 3 parallel direct buried circuits are required. This is because the current rating of direct buried cables is higher than it is for enclosed cables. This next example is based on example 3 from Appendix A of AS3008 and is for a three-phase circuit installed on a surface in a confined ceiling space. The three-phase circuit is installed in air on a surface. It is proposed to use 2 parallel circuits of V75 multi-core cables. The load current is 125 amps per phase and the ambient temperature inside the ceiling space is 50 degrees Celsius. The objectives are to calculate the minimum conductor size and maximum length of runs for a maximum voltage drop of 3% for both copper and aluminium conductors. The first thing we do is set the cable data. We set a 3-phase supply and permissible voltage drop of 3%. The installation is set as unenclosed and touching. The derating wizard is used for determining two derating factors, one for the grouping and the other for the ambient temperature. The minimum copper conductor size is 2 parallel circuits of 35 square mil, with a maximum length of run at 3% of 194 meters. For aluminium conductors, the minimum conductor size is 2 circuits of 50 square mil, with a maximum length of run of 159 meters. This example for 22 kilowatt motor cables is based on example 4 from Appendix A of AS 3008. The 6 multi-core V75 cables with copper conductors are installed on the same perforated cable tray and are supplying 6 identical motor loads. The objectives are to calculate the minimum conductor size for a permissible voltage drop of 2.4% for all 6 cables. Note that each of the cables has a different length. The common data for all 6 multi-core 3-phase cables is set. Permissible voltage drop is set to 2.4%. The installation conditions and the protection settings are also selected. The derating wizard is used for determining the derating factor for the 6 bunched multi-core cables installed on perforated cable tray. Finally, the length of the run is varied for each of the multi-core cables for determining the minimum conductor sizes while considering permissible voltage drop.